Hello and welcome to 5 Minute Math. Today we are looking at day 7 of our 12-day review of 4th grade math. As always, we are looking at items from the 2017 Release Star Test, that is from the state of Texas. Today we're looking at some input-output tables. We are going to be looking at some estimation and also at how we can represent unknown quantities. But let's get started with our estimation. We have a table here, and it shows the number of milk cartons sold in 5 days at a particular school. So we get this term here, estimate, the number of cartons. If you take a look at your answers, you know that none of the answers are very specific. They're each rounded to at least the hundredths place right here. And so what we need to know is that this estimation, it means about. It means we don't need the exact answer. We can round, but they don't tell us which place to round to. So let's look at a few different options. Let's see what happens if we round to the nearest 100. And I'm just going to kind of extend my table here. And I'm going to round to the nearest 100, and then we can round to the nearest 10. We can also look to see if compatible numbers are going to give us any different answer. So if we go to the nearest 100 here, we are looking at this, the 3, we're looking at the 4, the 3, and the 4. So those are the numbers in the hundreds place. And it's going to be this tens digit that's going to do the work for us. So when I'm looking at this 352, I'm thinking, is that 352? It's between 300 and 400, but where would it fall? Is it a little bit closer to 400 or a little bit closer to 300? And this 5 actually is going to make that 3 go up. 352 is just a little bit. 350 is the exact middle point. Just a little bit closer to 400. So I'm going to round that up to 400. Now, when I'm looking at this 426, I'm looking, is it between 400 or 500? And 426, that 2 is not big enough to make that 4 change. It's going to simply go down to 400. This 449 is really, really close. 449 is going to be just 1 away from going up. It's actually going to go down to 400. But you see how big of a drop that is. I'm thinking rounding to the 100 is not going to be super accurate, because this 449 round down to 400. If it was 450, it would have gone up. 373, that's actually going to round up, because this 373 is closer to 400 than it is to 300. So that's 400, and then 402, well, that's pretty close. That's going to be 400. So I've got 1, 2, 3, 4, 5 sets of 400, so that's 20. Add my 2 zeros. I see 2,000, and I see a 2,000 here, so that looks like it's probably going to be good. Let's go ahead and round to the tens place. I'm just going to write those over here on the side. Let me move this out of the way. So 352, that means this number falls between 350 and 360. And as you can tell, it's going to be a lot closer to my 350. If this number we're looking at, in this case, it's the 1's digit. If it's 4 or less, it's going to go down to the earlier boundary number, so down to 350. 426, rounding to the tens place here, so it's between 420 and 430, and it's actually going to round up to 430 because that's 6. It's going to make that 2 change. I've got my 449, and you know what? To me, this is a much better round. I'm going to round this 449. It's between 440 and 450, and that's only 1 away. So rounding and moving 1 place to me is a lot better than rounding and moving 49 places. And then we've got Thursday, so we've got 373. It's between 370, 380, and that 3 is going to make it go down. That's 370. And then 402, that's going to round to 400. That's only 2 away. So let's see what happens when we add these up. So I've got 5, 10, 20. And then I've got 5, 9, 13, and there's my 17 and 20. So it's the same rounding to the tens or the hundreds. So this is definitely my answer. It's going to be 2,000. Sometimes we get compatible numbers, and if we want, we can use some compatible numbers, and those are estimates. Those are approximations, but they don't always round. So let me take a look at our numbers. I'm going to just rewrite them here, because some of them will end up at the exact same, but some of them might move a little bit. So 373, and then 402. I see a few spots we can use some compatible numbers. So you're looking for compatible numbers. Those are numbers that just add easily. And to me, I think of quarters, 25, 75. So when I see this 426, I'm thinking of 425. They are like $4.25. 449, that's going to go to 550. But if I see this 373, to me, I think we can move that to 375, and that's going to go to 400. The reason I like this is because I know that this 25 and 75, that's going to make 100. 1550, that makes another 100. So now I've got 200. And then I'm going to have the same thing here. This is still going to be 2,000. But those are just three different ways. It doesn't really matter which one you use, because estimate means about. Means we need an approximation. We don't necessarily need the exact answer. So let's get rid of that, and we will look at our second problem for today. And that is going to be how we represent an unknown quantity. In this case, our unknowns, as you can tell, is in the answer. It's going to be the first number. It took Ian 3 years to collect, 25,413 aluminum cans to recycle. In the first year, he collected 8,917. In the second year, he collected 7,639. And then which equation can be used to find X, the number of cans that Ian collected in the third year? Well, when I'm thinking of this, I'm thinking that it took his first year plus his second year plus his third year. That's going to give me my total. And that makes sense. And they actually give us these numbers. So our first year is 8,917. The second year is 7,639. And then our third year, that's the unknown. So we're going to say X. We're just going to put a big X there. That just means we don't know what it is. And they actually gave us our total, 25,413. Now, you're not going to find a problem that looks exactly like this, because you notice that in this we have X as one of our add-ins, but here we're looking at X on its own. So one thing that we are going to learn in the upper grades in algebra is that it's called the equality rules, and how we can keep equations balanced. So when we think of a balance like this, and we learned this in the first grade, I think we have a balance here. And if we want to keep an equation balanced, if we put 5 on this side, we can put a 2 plus 3 on this side, and that's going to be equal. If we put another 1 on this side, now we're unbalanced. So we have to put another 1 on this side, and now we're back to being balanced. So whatever you do to one side of the equation, you can do to the other side of the equation. And so the reason that's going to be helpful is because we can take this 8,917, and if we take it away from the left side of the equation, well, you see that these two are just going to cancel out. 8,917 minus 8,917, well, that's just going to cancel out to 0. But in order to keep balance, I'm going to do the same thing to this side of the equation, minus 8,917. Then I could do the same thing with this. If I could take away 7,639, well, guess what? That's going to be a 0. But I've got to do the same thing on this side, 7,639. That keeps my balance. And now I've got my x all by itself. So if I write it so it's not vertical, I'm going to take my total, because this is our third year. So if I take my total, so in this case it's going to be big, 25,413. Then I take away my first year. That's going to be 8,917. Then if I take away my second year, that's going to be 7,639. If I take away my total and my first and my second year from that total, I'm going to be left with my third year. And so what we have here is we've got 25,413, and then we minus the first and the second year. And that's going to get us our answer of our missing third year. So the answer is going to be A. So that's the beginnings of algebra and how we can change equations. Just always think of this balance here. As long as you do an operation on one side of the equation, you can do the same thing on the other side of the equation. That becomes very helpful. And finally, let's look at our third problem for today. This is an input-output table. So we have a rule. Input-output tables have rules. The rule of plus 38 is used to show the relationship between the position of a number in a pattern and the value of that number. So we're looking basically is which number or which table has a rule of plus 38. And if you think about it, they actually give you the answer, because look at all of these rules we have in these expressions. We have 38, but it's plus 1, plus 2, plus 3, plus 4. So that's not going to work. And this is just 38, and then you do random stuff to it. Times 1 plus 0 divided by 1 minus 0. That's random. This is getting closer, but I've got plus 37, plus 36, plus 35. Those don't change. We need to see plus 38 to see the relationship between the position of a number in a pattern and the value of that number. So we have 1 plus 38 is 39. 2 plus 38 is 40. 3 plus 38, you notice my rule is going over and over, plus 38. So the answer is going to be D. And as long as you picked up this little tiny nugget up in the problem, that was a fairly simple one. So if you are interested in learning a little bit more, you can get onto my website, aarondaffron.com, and I've got another day, in this case day 8, in which we are looking at some more 4th grade math material.